Okay, let's do number 3. Here we want to find some derivatives. Okay, so for A, we're going to do the product rule. Alright, so y prime is equal to the first function, that's sine x, times the derivative of the second function. The derivative of cosine x is minus sine x, plus the derivative of the first, that's the derivative of sine x, so that's cosine x, times the second times cosine x. So written more concisely, we have cosine squared x, we can write it like this, minus sine squared x. Okay, in part B, we'll use the chain rule. First, we'll take the derivative of the outermost functions, that's these brackets with an exponent of 3, so y prime is equal to 3, bring down the 3, and then just copy over the inner function exactly. Okay, now we have an exponent of 2 here, and now we're going to multiply by the derivative of this inner function here. Okay, so let's do that. So we're multiplying by the derivative of cosine x squared. Well, the derivative of cosine is minus sine, so we have minus sine x squared. And continuing with the derivative of cosine x squared, we're going to do a little chain rule here. The derivative of x squared is 2x, so that's a result of the chain rule. Plus the derivative of 10 is 0. Okay. C, all right, let me rewrite this. We have y is equal to secant of sine x. So this is a composite function. The outer function is secant and the inner is sine x. Alright, so we have y prime is equal to, first we'll take the derivative of secant, and the derivative of secant is secant tangent. So we have secant of sine x times tangent of sine x. And now we're multiplying by the derivative of the inner function, the derivative of sine x, which is cosine x. Okay. All right, and our last part in this question is, I'll rewrite the function. It's y is equal to tangent of xy plus secant x. Now notice that we can't solve this function for y because we have y on the left side and y on the right side, so this is implicit differentiation. So let's start. The derivative of the left is y prime, and now we have the derivative of tangent. Here we're going to use a chain rule. Derivative of tangent is secant squared, so we write down secant squared and just copy over what's inside. And now we multiply by the derivative of the inside. This is where the implicit part comes in. We're going to do, here we have x times y, so we're going to do a product rule. So we have the first times the derivative of the second. For the derivative of y, we write y prime, plus the derivative of x, which is 1, so I won't write that, times the second times y. Okay, here we still have the derivative of secant x, which is secant x, tangent x. Alright, let's say we solve for y prime, like we usually do. Y prime is inside these brackets, so let's do the distributive law to open up those brackets. So we're going to multiply secant squared xy times the first term and times the second term. Alright, so let's do that. So we have y prime is equal to secant squared xy times xy prime, that's this first term here, plus secant squared xy times y plus, let me just copy over secant x tangent x. Now usually what we do is we put every term with y prime on one side, let's say on the left side, and leave the other two terms on the right side. So I'm just going to take this entire term, and subtract it onto the left side. So we'll have y prime minus secant squared xy times xy prime equal to, these two terms we're leaving on the right side, so let me just copy them over, secant squared xy times y plus secant x tangent x. And now let's gather together the y prime terms by factoring out y prime. So here we have 1 minus all this without the y prime. Secant squared xy times x equal, and then we have all this entire right hand side, which I have to copy over again, secant squared xy times y plus secant x tangent x. And like we always do in the last step, we divide both sides by whatever's multiplying y. So in this case, we'll divide by this expression here in the square brackets. Just like that. 1 minus secant squared xy times x. We divide both sides of the equation, left and right. Now these cancel top and bottom, and we have y prime equal to this expression here on the right.